Hello. Everybody should be entering. Is the same? Is everything seem okay? Can you hear me? Let me see. Let me get the
Yeah, we
chat
can
up.
hear you.
Yeah. Okay. Great. Thank you. Okay. It looks like almost everybody's in already. So I'm going to go ahead and switch to screen sharing. Okay. Okay. And you should be able to see the desktop now. Okay. Um, so first of all, there'll be another homework assignment up there real soon, probably by well, it might be up there before Wednesday even, but there'll be a homework assignment up there on Wednesday. Your last homework assignment was due last week, and so there'll be a third one up there soon. And I, I have, today we're going to talk about this reading assignment here. Okay, that's what we're going to do today. And the reading assignment for Wednesday is the next couple sections. See, this was 2.1 through 2.4, and then in the same book, 2.567. These sections add a little bit to what we've been taught. They go over what we talked about last week and add something new. So last week we were talking about methods. So we did these examples involving defining methods. Okay. So we wrote examples of defining methods. Okay. And that was based on chapter 4 of this book. Now we're moving to this chapter 2 of the other book, which is about, you can see methods and methods and methods, but it's also about objects. Okay. So we're talking about the thing we're adding new is this idea of objects. That's what we're going to talk about mostly today. Java is called an object-oriented programming language. It's a whole class of languages. It includes C++ and Java and JavaScript and Python. They're all what we call object-oriented programming languages. Okay, so we're going to start about objects, but objects are closely related to methods. Okay, you can talk about methods without talking about objects, but you can't talk about objects without talking about methods. So we talked about methods first from this book. This book waits a while to talk about objects. It doesn't talk about objects until a little bit later, but we're going to just tie objects and methods together like this book does, because that's a pretty common way to do it. All right, so today, the new thing we'll be adding is objects, and we'll also be reviewing some ideas of methods. And then besides that, there's one other thing here. I put up another version of this CS123 zip folder. Go ahead and download it. If you just click on it, you'll download it. Now, I already downloaded it. So, well, let me show you. If you unzip it, I added a couple things to it. I added a configuration file. And in the configuration file, I made it so that Dr. Java has a light and a dark mode, which makes it a little bit nicer to work with Dr. Java as an editor. And I also put in the config file the stuff we're going to be talking about today from this book, something called Turtle Graphics. I added the Turtle Graphics to Dr. Java. And I'll show you as we go along, we'll look at that. Now, unzip this and copy it to your C directory, which I've already done here. Okay, so copy it to your C directory. Okay, so I've already done that, so I'm just going to delete these. Now, I named it CS123 version 2 so it wouldn't clobber your previous version. Yeah, if there's something about your previous version that you've changed that you like, I didn't want this one to clobber this one. So you can have them side by side. Okay, they don't affect each other. Okay, so in here is these are what is to make let me show you what it looks like. To make Dr. Java work in a light and a dark mode, I had to create a special configuration for it that's in here. And then I have to create a little command to start Dr. Java. If you start Dr. Java this way, it ignores what's inside here. Okay, so it won't pay attention to what I put in here if you just start Dr. Java this way. But if you start it this way, it comes up in a colored mode that's a little bit more pleasant. Okay, and let me show you what code looks like in this. Okay, this is what's next called a light mode. Okay, and then you can close that. And then there's another mode. Dr. Java doesn't know how to switch modes, so I had to create two different configurations. If you double click this one, you get Dr. Java in a dark mode. Here's what the code looks like. Oops. Here's what the code looks like in it. Okay. A little bit easier to work with, a little bit more pleasant. Okay. Okay. So, and it still works the same way. You can you compile, run. Okay. See, there's what the output looks like in the output window. The windows now are dark and the text is lighter. Okay. All right. So if you prefer working in an environment like this, uh, you can download this version of Dr. Java. And if you're curious, I mean, I can show you real quick how I did this. If you go to Preferences, Dr. Java has a Colors tab where you can set the colors of a bunch of different features of Dr. Java. And then what I did, there's a famous color scheme called Solarize. Solarize is a really well-known color scheme that a lot of programming environments use. And it's a palette of these colors. And I used this palette of colors in Dr. Java. I essentially copied the appropriate value from this palette into these options in the right place. I didn't touch any of these. These colors down here don't seem to get used very much. So I wasn't changing any of these. These are the ones I changed. Okay. So uh, this palette is both for light and dark mode. See, it does both light and dark mode. Okay, it's you kind of reverse the palette. You work from left to right to get one mode, and from right to left to get the other mode. Sort of, well, up here. You work from left to right to get dark mode up here, and you work from right to left to get light mode up here. And then these colors are the things that don't change color between light and dark mode. You use these colors for things that don't change with the light and dark. Okay, it's an interesting idea. And this Solarize is used by a bunch of programming environments. A lot of people like it the way it looks. Okay, and it was designed to give you a complementary light and dark mode. That's usually not, it's not a really common way to do things. And that's one thing that makes Solarize so unique, is that it has a complementary light and dark mode. Okay, so that's what I did. I configured Dr. Java with these colors. And then just show you one last step. Dr. Java remembers this in a file that's in this config file. So this is where Dr. Java remembers these things. Okay. This is where it remembers all the colors, like the colors are in here. Okay. This is typical of the way programming environments work. They have a configuration file where they remember your choices for things. And then this thing here, which glues it together, this thing here says start Dr. Java using that configuration file. Okay, so you have to have that. If you just start Dr. Java, it uses its own configuration, not the one you want. So if you just start Dr. Java, like if you just start Dr. Java here, it ignores my configurations. It uses its own internal configuration. Oh, wait. Oh, it default. Oh, I don't even know why it did that. Wait. I may have I may have managed to change Dr. Java's internal configuration. I'm not sure why that's actually happening there. Okay, yeah. But I have to look into that, why it did that. But this one starts Dr. Java in dark mode. This one starts Dr. Java in light mode. Okay, okay. Probably in my playing around, I may have changed Dr. Java's default configuration. All right, now you can create shortcuts to these on your desktop. That's what I did here. I created shortcuts to this and this on my desktop. So I can bring up either the light mode or the dark mode. They both look pretty good. I kind of like the light mode a little bit better myself, but they both look nice. All right. So again, if you want, you can download this zip file once again. It lets you, it gives you these two modes, but it also lets you work with what we're going to talk about today. We're going to talk about something called Turtle Graphics. And I'll show you before the end of the class that this Dr. Java now has the Turtle Graphics built into it. Okay. So, and um, if you try it and anything doesn't look right, let me know. Like if you try these modes and there's no guarantee that these are going to work on everybody's computers. Windows is such yeah, Windows can vary so much from machine to machine. Like you may not have the right font or something like that. I think this will work on almost everybody's machine. But if you want to try it and somehow it doesn't work, like let me show you one thing. Open code in it and see what the code looks like. The code should look nice and crisp. If it doesn't, it means you don't have the right font. If the code looks kind of ugly, there very well could be that your computer doesn't have the right font on it. Like if you go back here, edit, preferences, you check font. And the font I'm using is something called Consolus, which is a very nice font. And I think it's now included with all versions of Windows. It didn't used to be, but I think it's now, but that doesn't mean I think it's on all versions of Windows. And it won't be on Macs. I doubt it. I mean, you could probably add it to a Mac, but I doubt if it would be there on a Mac automatically. So I'm not sure what you'll get on a Mac. So if you open this, if the text doesn't look really good like this, there's probably a missing font. So if something doesn't look right, ask, and we can try to track down like how to fix it, or what might have gone wrong, because there's so much variability in Windows. It's hard to build things that work across all versions of Windows. It takes real effort. That's what professional programmers have to work on, is to get things to work on all versions of Windows, let alone Windows, Mac, and Linux. It's hard enough just to get things all working on Windows. Okay, so if something looks a little bit blurry, okay, now let me see. Here's the light mode. Similarly, the code should look good. The code should look good. And this one I chose a different font. This one, the font is something called Courier New. Okay, which again, that one I'm positive is on every version of Windows. Okay, and probably on almost every, maybe on Macs also. Okay, so, and if you want, you can switch. The fonts they're not quite the same font. I thought this font looked a little bit better here, and this one looked a little bit better here. Okay, they're not quite the same, but they're real similar. Okay, but if you open a text file and something doesn't look right, like when I tried a couple different fonts, things would look fuzzy and unreadable. It's kind of odd. Not every font would work with this stuff. So I had to choose a couple different. I had to look for a font that worked. Okay, this font, this font here, well, actually, both these fonts tend to work everywhere. Consolus and Courier tend to be fonts that'll work everywhere. So they're kind of obvious choices, but I tried some other fonts and they didn't work. So yeah. So okay, if yours doesn't look quite right, let me know. Send a screenshot. Like if you think it looks weird, send a screenshot. We can try to figure out what's wrong. Okay. Okay. So okay. Then now, well, now we're going to go switch to working in the textbook. So we're not going to use Dr. Java. We're going to go to look at this section of this book. This section has the code built into it. So we're going to look at their code built into it, and then we'll see that we can copy and paste that code into Dr. Java and play with it in Dr. Java also. Okay, so here's the thing. We want to talk about these things called objects. Like I say, Java is an object-oriented programming language. So an object is a bundle of data. okay? In programming language, well, actually, what an object really is, it's a way of trying to model something in the real world. Okay, so in a programming language, if you're writing a program that's going to for a company, and a company has employees, you need to model employees. You need to keep track of each employee in the company. So what you do is in a language like Java, you define something called an object, an employee object. And it would hold, for each employee, there'd be an object, and it would hold things like their name, their social security number, their age, birthday, address, their salary. So you would have all these what are called fields in the object, which is all the data. So an object is something that represents something in the real world. And it's a programming language idea of some objects in the real world are represented by data. So an employee would be represented by things like his name, social security number, age, birthday. Another example of an object in Java are strings. A string is an object in Java, and it models a sentence in text, and the string's data are the letters in the string. Okay, so a string is an object, and it holds letters. Okay, an employee object would hold all the information about the employee. Okay, anything you can think of, you could say, oh, what would a car object hold? So you can model a car, and it could have its make, its model, how many miles are on it, what the license plate number is, who owns it. Okay, so whatever data you want to put in, and the data would be things, the data is always going to be ints, doubles, strings. Okay, so when you have an employee, the name would be a string, the age would be a number, the birthday, that can go either way. You could represent a birthday as a string, like January 22nd, 1975, or you could model it as a bunch of integers, month, day, year. And actually, different people choose different ways to model dates. So a date could be one string, it could be 3 integers for day, month, and year. Okay, and so every object is going to hold data, and the data is going to be a combination of strings, ints, doubles, uh, and also sometimes booleans. Like if for a boolean, like if an employee, you'd want to record if they're male or female. So you could say, you could have a field called female, and then it would be true, meaning they are a female, or be false, meaning they're not a female. Okay, so you could do something with a boolean. Okay, you could have a field that says currently employed. So maybe your database is a record of all the employees you ever had. So you'd have a field in there currently employed. And it was true, the person's currently employed. If it was false, they would be previously employed. So sometimes we'll have booleans in our classes. So the classes hold a bunch of data, and the data uses the variables like we've been talking about in the first chapter or so of the book. Okay. Now, as an example of an object, this book uses a real famous example, something called a turtle. Okay. The turtle is used in a lot of books as an example of an object that you can play around with. Okay. Now, in this environment, what we mean by a turtle is something that draws pictures on a screen. Here, it used to be the turtle was a little robot. You think it was like a little robot that moved around and drew on a piece of paper. In modern programming language, the turtle is an object. Here's the turtle object in the code. Let me run this code, and you'll see what it does. The turtle object running. It'll take a little while to get going the first time. There's the turtle object, and he draws on a screen. This is a screen, and the turtle's used to draw on the screen. So the turtle object represents this turtle. Well, we're going to see the data in it are things like what color is he, where is he on the screen, what direction is he heading. Okay, so this turtle is an object that holds a bunch of data. Okay? And then what we do is we call methods on that object. The other important idea is what an object is, and then what we do with an object. What an object is something that holds a bunch of data. then what we do is we call method. See, there's a method name followed by parentheses. So just like last week, that's how you call a method. If you go back and look at last week's code, see, we called a method, the name of the method, and then empty, in this case, it was empty parentheses because the method didn't have any parameters yet. See, there's the name of the method. You put a pair of parentheses, so that was a method call. Now, there's no object here, and that's what's changed now. There's no object that this method is acting on. That's what it's what we've added here. This method is a method on that turtle, saying to that turtle, change your data. What the methods do is change the data in the turtle. So what this did is told the turtle to change where he is. The turtle was there, and the turtle was told to move forward to there. So that actually changed data in the turtle. The turtle's location changed from here to here. And in the process of moving from here to here, the turtle draws a straight line. Okay, so every time you move a turtle, wherever the turtle when the turtle moves, it draws. And this is the trick. This allows you to use a turtle idea as a way of drawing geometric pictures. Okay, it's called turtle geometry. People refer to this as turtle geometry. So when you tell a turtle to move, you're telling the turtle to change its data. The turtle initially was at the origin. See, that's at the center of this square. So that's 0, 0. Then you tell the turtle to move forward. I think it moves forward 100 units. I think this is about 100, what are turtle units. So this moves, I think, 100 units. Then the turtle was pointed in that direction. That's one of the pieces of data it remembers, what direction it's pointed in. This says to make the turtle point west. See, the turtle was initially pointing north. Turning left makes him face west. Then you go forward again, so he moves to that location. Okay. Now, notice there's another object in this thing. There's also a world object. That's this 300 units by 300 unit screen here. Okay, so this is a new world object that's 300 units by 300 units. Okay, then the turtle is in the world. Okay, this is how we start. We create a world object. The world object's data is how big it is and how many turtles are in it. So the world remembers, oh, and also the world remembers what's been drawn on it. So the data of the world is how big it is, how many turtles are in it, and what have the turtles drawn on its, if you think it's like a sheet of paper, what have the turtles drawn on it? That's the data in the world. The data in the turtle is where he is, what color he is, what direction he's headed. Okay. Now here we said move the turtle. When the turtle was created, he's at the origin, the center of the world. Then he moved forward. Then he turned left. Then he moved forward again. After you've told the turtle what to do, you have to tell the world to show itself. The way this thing works, this stuff isn't drawn until after you get to here. Okay, that's just the way the graphics work. The last line of the program should be world.show true to make the picture show up. Now, for example, I could make the turtle. I could add constructions here. Make the turtle turn left again. Okay, and make the turtle go forward again. Okay. Now I've added some code to this. I'm making the turtle turn left and go down here. So I can click run. It'll recompile and rerun it for me. And now I've got a slightly new version of the program. It's slow today. Their website. Remember, this isn't really running on my computer. This is actually running on the computer of the people who own this website. They run it on their computer. So maybe there's a lot of other people using it today. Okay, so now it went forward, turned left, went forward, turned left, went forward again. Okay, all right, all right. So we're gonna use the turtle as an example of a way to think about objects. And in a little while, we'll use strings as another example as a way to think about objects. So a turtle is a good example of a kind of a fairly complex object that, now it's not really representing a turtle in the real world. What it's really representing basically is the ability to draw. The turtle's a kind of it was designed for teaching children programming, so the idea of a turtle was kind of appealing, but it's really a way to model drawing. So the turtle is representing, yeah, they didn't call it a pen because that wouldn't excite kids. Of like, I'm programming a pen. But the turtle actually is considered to have a pen in his stomach, and when the turtle moves, the pen is drawing. In fact, you could go up here and you can say, tell the turtle to raise his pen. You tell it to raise his pen by saying pen up. I can't remember if it's, yeah, I think it's pen up. Okay. Now, if the pen is up on the turtle, when he moves, he won't be drawing.
Professor, you spelled the
Oh, I spelled turtle, yurtle wrong. Yeah. So now it's going to, yeah. So I misspelled yurtle.
Would you recommend that because this, like you said that version 2 does the turtle thing, would you recommend for all of us to get the version 2 of Java, Dr.
Yeah,
Java?
yeah. Eventually, because it might give you, especially if you have a homework assignment using the turtle, it might be better to work in Dr. Java than to use this website.
Okay.
Like you can do turtle programming in this website, but it might be nicer to do it in Dr. Java.
Mm.
Okay, now let's see. Boy, it's slow today. Now, see, the turtle raised his pen. Oh, I forgot to drop the pen down. Then I wanted him to do, after he's moved forward, I want him to do pen down. It's really the pen that's important. You can change the color of the pen. I mean, this was designed for children, so they thought of it as children would like the idea of programming a little robotic turtle. But it's really modeling a pen. When you draw, you put your pen in the paper, you move the pen a certain way. You might lift the pen up and then move, or you might keep moving with the pen down. At some points, you might change the color of the pen. So it's really modeling a pen. Pen up, so he moves with no drawing. Pen down, he moves with drawing. Yeah, okay. And you can change the color of the pen. So what we're really modeling is the ability to control a pen. Okay, and then we can do some real interesting graphics. We'll see that when we learn a little bit more about programming, we can draw actually you can draw beautiful graphics with this. The turtle's powerful enough that you can draw beautiful graphics with it, all kinds of fractals and all kinds of geometric shapes. So we'll see as we go along how we can do different things with the turtle. Okay, but you can see in this picture, it was actually used with children. This is from the 1960s. They actually at MIT. This was done at MIT. They built this turtle with a pen inside of it, a marker, and they gave it to children, and the children programmed it using this box over here. So this was like one of the early attempts. The people who did this at MIT in the 60s were the same people who eventually created Lego robots. This turtle became Lego robots. It's the exact same group at MIT. Okay, so this was their first attempt to use robots to teach children, but they called it a turtle. Okay, because they didn't want to tell children they were programming a pen. That just wouldn't have like maybe sunk in some. It wouldn't have been as appealing to the children. Okay, all right. So a turtle or a pen is a good example of a real world object that we want to model in a program. And what do you do with a pen? You touch it to the paper, you move it around, you raise it up, lower it down, change the color. You can also change the thickness. I mean, an artist would tell you that when they're drawing, they'll adjust the thickness of their strokes. Turns out we can adjust the thickness of what the turtle draws. Now, each thing we do to the turtle, now the turtle's got all this data. So the data he would remember is, run it. He's going to remember where he is, what direction he's pointed in, what color his pen is, whether the pen is up or down. He'll remember the thickness of his pen, so you could change the thickness. So when he draws, he'll draw at different thicknesses. So the turtle's storing all this data. It remembers all this information about the pen, mostly. Up, down, thickness, color, where it is, what direction the pen is currently moving in. We call methods on the object to change that data. By changing where the turtle is, we cause him to draw if the pen is down. If we change where he is and the pen is up, he doesn't draw. Okay? If we want to, we can change the color of the pen, the thickness of the pen. Oh, and also, they didn't do it here, but I can create multiple turtles. Okay, so I can create multiple pens. So I'm going to create a second turtle. In fact, and what I'll do is I'll create this after the first turtle's played. So that turtle does a little bit of work. Now I create a second turtle. I'll have that second turtle do the same. Well, I'll have that second turtle do almost the same thing. So this will be Yertle 2. But I'll have I'll have I'm going to have the first turtle start off by going down. So he's going to turn right and then turn right again. If he turns right 2 times, he'll be facing down instead of north. Then have him go forward and then turn, let's see, turn left and then forward. Okay, so now I'm going to have one turtle go up like this, and I think I'll have the other turtle go down and like that. So, but I can create as many turtles as I want. They're separate objects. Each turtle has his own set of data. You know, if you think about it, they're like, if there was like 2 of these mechanical turtles up here, each one has its own set of data. So when I give commands to one turtle, that doesn't affect the other one. So there's the first turtle. Now here's the second one. Okay, right? So there's 2 turtles on the screen. Each turtle remembers where he is. Each turtle obeys his own. Now, you notice that I use the same commands, but on a different turtle. So this method acts on that turtle. And what it tells the turtle to do is move forward. The same method acting on this other turtle tells that turtle to move forward. Okay, so notice I'm calling the same method, but it doesn't do the same thing. It does the same thing to the turtle it's being called on. That's real different than what we did over here, where we just called a method. Every time you call that method, it'll do the exact same thing because it's not acting on an object. See, there's no object attached to this thing here. These are called static methods. These kinds of methods that don't have an object are, there's the words right there. That's what they're static methods, methods that live independent of any object. These now are methods that are tied to an object. Okay, so when you call forward, it makes what you can't. Oh, you cannot. This wouldn't make any sense. That makes no sense. Who's going forward? If I try to compile this, I'll get an error on this line eventually. Boy, it's really slow today. There were errors compiling your code. See, forward didn't just by, it's not a static method. It can't live by itself. It's not one of these kinds of methods. It's a special kind of method, a method that always has to say what object, it needs to have what object it's acting on. Okay, all right. So this didn't work. This is not a freestanding static method. So we switched to objects and method. We call this a method on an object. So that doesn't make sense now, as opposed to that making sense. That's just but that's a method that doesn't act on an object. When you call that method, it does something. It does whatever code, it does the code that's in the body of the method. Okay. So whenever no matter where you call that method, it always does whatever's in the body of the method. Okay, these kinds of methods, we'll see later how to write them. We actually don't know yet how to write these methods. We're just seeing how to use them. These are written slightly differently than these static methods. They're written in a different way. And what they do is they're methods that act on objects. Okay, now, when we worked last week, remember we showed that you could give a method a parameter, like a function in a math class. You could say 3 lines and print this message on each line. Okay, so we had the method taking a parameter. Okay, now these kinds of methods can also take parameters. Now notice so far, no parameter, no parameter, no parameter, no parameter, no parameter. So watch, I can make these things take parameters by saying go forward a certain amount. Instead of going forward whatever the default amount was, I can say go forward, say I'll make it 50. Okay. Now this world is 300 units by 300 units, so 50 is 1/6 of the size of the screen. So it's going forward a medium amount. Okay, all right. And let's see, I'll make this guy go forward 50 here. So I'm giving parameters to a couple of the method calls.
If you put a negative in one of those parameters, like for the distance, would it
That's
go
a
back
good question.
for instance, or would it, say no?
It would make sense that you would have them move backwards. And the question is, did the person who wrote the method make it work that way or not? So you have to, you could try it, or you could go, yeah, was just, okay. Now there's a short jump. That was 50 units. See, that was a short, and then this is, the default was 100 units. Okay, so now let him go -50. Okay, now -50 is either going to be an error, or maybe he'll go that way, which would be going, he's facing that direction. No, yeah, he's facing that direction, but in negative direction usually is the opposite of what you're facing. Usually that's what you would mean by a negative direction, the opposite of what you're facing. So let's see if it was what he does. The person who wrote forward could have not allowed you to use a negative number, so you could get an error, or it could just do the right thing, or it could ignore the negative sign and just do 50. I don't think that would be the wise thing to do. Let's see what it does. I have a feeling it goes backwards. Yes.
All right, cool.
Yeah. So they wrote it to kind of do the right thing. Negative number just means go backwards. Okay. All right. Okay. Now, what's another parameter you can give these things? When you say you turn left and turn right, those always turn by 90 degrees. That's what it means to turn left or turn right. You can also just say turn, not left or right, but then give an angle to turn by. Okay, so there's turn by 45 degrees. That's a parameter, 45-degree turn. So some of our methods can take parameters and some of our methods don't take parameters. Notice that some of them, okay, let's see this. Boy, it's slow today. Oh, no, wait. Oh, that time it blew up. Server error. See, server is this computer we're talking to. The computer is probably a little bit overloaded today. So the server didn't, so let's just try running that again. If this blows up again, I'll switch to Dr. Java. I'll just copy and paste this into Dr. Java. Okay, their time it worked. See, there was the 45-degree turn. See, he's painted in the 45-degree direction. Okay, notice turn right doesn't take any parameter. It means turn by 90 degrees. If you put a parameter in there, you'll get an error message. turn has to have a parameter, I believe. Like, let's not give turn a parameter. Let's just say turn. What will turn do? I think it'll give us an error that turn has to have a parameter. Okay, required a parameter. Okay, now this is kind of one of the things we have to learn is how do you find out this stuff? How do you know when a method requires a parameter or it's just optional? So for example, forward didn't require one, but you could put one in, there. Turn left, now let's do something. Okay, turn requires a parameter. Now what about turn left? What if I said turn left 45 degrees? Let's see what happens. Turn left 40, sounds reasonable. Turn to your left 45 degrees. Error. Turn left, no arguments. Required, no arguments. Okay, so now somebody wrote this, and what we're going to learn is we have to learn what their rules were when they wrote this. They decided that turn left, no parameters. It's always 90 degrees. Same with turn right. Turn, on the other hand, always needs a parameter. You always have to say how much to turn by. It doesn't have a default turn. On the other hand, forward, different than both of those. Now, turn left requires no parameter. Turn requires a parameter. Forward, you could either give it a parameter or not give it a parameter. Now, that's confusing. Like, there's all these different ways of doing it, and we'll learn. You have to read the. There's a way to find out these things, to ask these questions about what parameters do these methods require or not require. Okay, eventually we'll see the code. Like here, we wrote 3 lines, so we see it needs a parameter. We wrote new lines, so we see it needs a parameter. Over here, we didn't write forward, turn left, forward, turn. We didn't write them, and we'll learn how to find out what they require. There's going to be documentation that spells out their rules. What are the rules for using these methods? Okay. Right now, the rule is forward will move forward 100 units. If you don't tell it otherwise, it moves 100 units. But you can tell it any amount of units you want. Turn left always turns 90 degrees. You can't tell it what to turn. Turn has to be told how much to turn by. So it requires a number. Okay. And pen up and pen down would be another example where pen up just means raise the pen. You don't raise the pen by an amount. So pen up would never take, there would be no reason for pen up to take a parameter. Pen up and down is just a Boolean. The pen is, it's either true that the pen is up or it's false that the pen is down. So pen up just changes that. If the pen is up and you call pen up, it doesn't do anything. And if the pen is down and you call pen up, it effectively raises the pen. It doesn't make any sense to raise the pen by an amount. So pen up wouldn't take a parameter. But we have to learn where you would find all those different rules. Okay? All right. Now, I can create as many. Here's the, see, the word new is used to create a new object. So I'm creating a new turtle object. Notice that turtle's in capital there because that's the name of a type of this is the name I gave that turtle, but this is what it is. Yertle is a turtle. So we say Yertle is a turtle because it was built, it's what we call a turtle object. So I created a turtle object and I named it by this. This is the name of what it is. This is the name I'm calling it by. Here I created a world object. That's the screen the turtle draws on. I called it world with a lowercase. Okay. I can create more than one world. Let me create a second world. So down here, I'm going to create world 2. I'm going to make it a smaller world. I'm going to make it a little 100. I'll make it 200 by 200. Okay. I'm going to create a smaller world. And then I'm going to create a third turtle. but I'm going to put the third turtle in the second world. So I'm going to create a turtle called Yertle 3, and he's going to be put in world 2. Okay, and then I want that turtle to do, I'll just make it do this little dance here. So I'm creating a world object and calling it world 2. The original world was called world. The new world is called world 2. Then when I create a third turtle, I put it in world 2. That's the name I gave to the world. World 2 is a world, but it's called world 2. Now down here, I gotta make sure these are all Yertle 3s. Okay. Now I need to show my second world or it doesn't show up. So now I have to say, and world 2 should show true. Okay, so I want it to be true that the world is showing. Okay, and you have to do this after you've done all the commands. I tried it, I did an experiment. I was curious. If you show the world right away, it doesn't work. The commands have to come first, and then the last thing you do is show the world. Okay, that's just the way they wrote it. You have to learn what their rules are, and it's, you know, we're gonna see, we're gonna learn how you learn what their rules are. Okay, right. So right now, one of the rules is that you don't show the world until after you've done everything. Okay, now let me run this. Let's see what it looks like to get 2 worlds. Slow, slow, slow. Didn't, okay. Okay, there's world 1 and there's world 2. Okay, notice by making this turtle go 100, he put him right on the edge of that world. Notice how he was, yeah, he's half cut off because I forgot that world was smaller. So when he went forward that much, he's right. It just happened to be right on the edge of the world. Okay, all right. So yeah, I'm doing object-oriented programming here. I'm creating objects and calling now I'm not calling any methods on the world other than putting a turtle in the world. Actually, I'm not calling any methods on, the only method I'm calling on the world is to show itself. So the only method I'm calling on the worlds is to make them show. Okay, okay. And I'm creating turtles. I create turtle, this turtle, this turtle, and this turtle. I put 2 turtles in the first world and 1 turtle in the second world. So I'm manipulating, I'm doing what we call object-oriented programming. Creating objects. Somebody else wrote all this stuff. Notice that I didn't write the code for world and I didn't write the code for turtle. I'm using somebody else's code. I'm using their methods. Unlike over here where we wrote methods. Well, actually, over here, we are using methods we didn't write. Now notice that there's a method on an object. See, now we can see print line is a method on an object called out. Okay, we didn't write this object and we didn't write this method, but we've been using it. So there's a method on an object. Okay, but we wrote this method and then we could call it here. So we knew what this method did because we wrote it. And we knew what this method did because we wrote it. Okay, we know what this method does because we learned it. We're told what this method does. We didn't write it, we didn't look at its code, but the book told you what that method does. Okay, so notice you can learn what a method does by reading it because you wrote it, or you can learn what a method does because the person who wrote it explains it to you. In this case, this was explained to us. Okay, now over here, all these are things that somebody else wrote. So we're I'm right now, the book is explaining to you what they do, and I'm explaining to you what they do. Later on, we'll see how you could look up for yourself what they do. We'll see that there is a way to look up what they do, but we'll talk about that a little bit later. So right now, we're just kind of, the book tells you what you need to know about what the turtles do, what methods there are on a turtle, what data the turtle holds, and what methods you can use on the turtle. Okay, The data is, like we said many times, the data in a turtle would be where he is, where he is, what direction he's pointing, what color his pen is, how thick his pen currently is, okay? Whether the pen is up or down. Okay, there's other data too that the turtle has, but we'll see. Yeah, for example, you can make the turtle grow. You can make the turtle's line get thicker, but if you want, you can also make the turtle just get bigger. It's not very useful because the turtle still draws the same kind of lines, but you can actually make the turtle appear bigger. Okay, so you can control the size of the turtle if you want. You can control the size of the line he draws. That's independent of drawing the size of the turtle's appearance. So there's a lot of little things you can change in the turtle. There's a lot of data that the turtle holds inside of him. The idea of holding data inside of something is what we mean by objects. Objects are these programming things that hold data in them. Oh, one thing, let me see, where should I go? That's a variable, right? And it holds something, 5. That's not an object. Okay, not everything that holds data is an object. Okay, this is not an object. It's what we call a primitive variable. So the primitives are just potentially numbers and booleans. Numbers and booleans are not objects in Java. They are in some languages. A number is an object in some languages. It's not in Java. So that's a variable, and you can't call methods on that variable because it's not an object. It's just a number. Okay, so there are no methods. There's no x dot that I can do on an int. Okay, strings actually are objects. We haven't seen that yet, but strings are objects. Like that's a string, and that's a string. We'll see that strings actually are objects that we can call methods on, and we'll do that. That's coming up pretty soon in the book. Okay, so this variable points to that turtle, but what that variable holds is the object. It isn't like x, which holds just a number. See, x just holds a number. This variable actually holds the object, that is the turtle. So it's actually holding a lot of data. Yertle holds a lot of data because it holds all the stuff that's in that turtle object. Okay, so and then when variables name objects, you can call methods on the variables. If a variable names a number, you can't call objects on the variable because it's not. You can't call methods on the variable because the variable's not an object. So Java has what are called primitive variables, which are not objects. Okay, and primitive variable pretty much means numbers, ints, doubles, and also means booleans, ints, doubles, and booleans. Those are the primitive variables. Okay, you can't call objects, you can't call methods on those. Everything else would be an object. And notice that I didn't use the word new here. I didn't say new int or anything like that. I just said int x equals 5. To create an object, I have to say, okay, here's a name for a turtle, but to create the turtle, I have to say new turtle. Okay, so you have to tell Java to build the object. In fact, this is called a constructor. When you use new, the name of an object, you're using something called a constructor. Okay, notice that the word turtle appears on both sides. This is telling Java this is the name of a turtle. This is telling Java to build a turtle. You can do funny things like.
So quick question, Professor.
Yeah.
Yertle will be the object, correct?
Pardon me?
Yertle, the name of the turtle, would that be considered the object then?
That's in a way, no. Like okay, watch
Okay.
this. Here's my fourth turtle name. I'm not going to create a turtle now. I'm going to say, did I spell that right? Yeah. Okay. Okay. What I did is I created a name for a turtle, but I did not build a new turtle. I said that that name equals Yertle. What I've done is I've given this turtle two names. So Yertle is a name for that turtle, and Yertle 4 is a name for that turtle. Neither one is actually the turtle. The turtle lives by himself. These are actually names for the turtles. Okay, it's a little bit tricky. Okay, now what can I do? For example, if I go down here and say Yertle 4 dot forward 100. Yertle is going to move forward because Yertle 4 and Yertle are two names for the same turtle. Yertle is one name for that turtle. Yertle 4 is another name for that turtle. So if I give a command to either of those names, I'm commanding the same turtle here. So we actually say that Yertle's not the turtle. Yertle's a name for the turtle. And another way to put it is, you're not your name. If you had never been given a name, but you'd been born, you'd still be a person. You know, you're not your name, you're a person. And you could have many names. You could have a nickname, you could have an alias, you know, so you could have many names. And that's exactly what's here. This is the actual turtle. This is
So
just
being turtle, the object.
pardon me?
I'm sorry. So turtle being the object and the name of the object being Yertle.
Yes. And,
Okay.
and what we do is we actually draw a picture. Let me just draw. We're going to draw pictures. Here's what we're going to draw a picture that looks like this. Here is a turtle object. Now over here, this is what our program is going to look like. Over here is going to be a turtle variable. Actually, I should have said this is over here is a turtle object. I forgot to put the word object after that. This is a turtle object. Here's a turtle variable, okay? And in it is Yertle. Actually, no, that's not where, over, and here is the name Yertle, okay? And what we have is, literally, we think of it as there's an arrow in here pointing to that guy. Now, I have another turtle variable over here. This turtle variable is called Yertle 4. Was that the name I used? Yertle 4, right? Now, it also pointed at the same object. See, I can draw that. Okay, this is what we really mean by this. That's what this code does. This is a picture representation of this idea here. New Turtle created this turtle object in the computer's memory. That's created by New Turtle. Turtle Yertle created this turtle variable called turtle. The equal sign here said, oh, but you're pointing at that object. Then I created a second turtle variable. See, turtle Yertle 4 creates a turtle variable. That's this box. It's called uRTL4. And this equal sign said, take what's in this box and copy it into this box. So it copied that arrow into there, and I end up with two names for the same object. So I have two turtle names and one turtle object. Okay. Now then down here, I create another turtle object. So if I was to follow my code a little bit more, I would have another turtle object. This is another turtle object. This line of code here, line 16, created a turtle variable. Oops. Line 16 created another turtle variable. Notice I got turtle objects and turtle variables. And it's real important that we're going to see that we treat these very different. Turtle objects and turtle variables. Notice that they're created on different sides of the equal sign. On the right are the turtle objects. On the left are the turtle variables. Line 16 created a turtle variable named uRTL2. Okay, whoops. Now, the line 16, the right-hand side created that turtle object. The left-hand side created this variable uRTL2. The equal sign said that this object is a name for, that this variable is a name for that object. Okay, so the equal sign said this variable is a name for that object. So I've got this turtle object with two names and this turtle object with one name. Now, here's something interesting. What's inside that box? What's inside that box are a bunch of variables like pen color. Inside that box is the location of the turtle. I'll write it as X, Y, location of the turtle. Inside that box would also be the pen up, pen down. The Boolean, pen up, pen down. Now, these same things would be down here. This guy would have a pen color, but it could be different. See, each object holds this data. This object has its own, this turtle has its own X, Y coordinates. This pen has his own sense of whether this turtle has his own sense of whether his pen is up or down. Well, what's another one? Oh, pen width. They each have a notion of what their pen width is. Oh, they're actually, one thing we worked with was heading. You know, what direction are they pointed in? So each turtle has its own heading. Okay. When you call a method on this turtle, you're affecting this data. When you call a method on this turtle, you're affecting this data. But notice that you call the methods on a turtle name. So it's kind of indirect. How do you call a method on this turtle? Well, you go over here to that name and you call the method on that name, which calls the method on that turtle. Let me show you a really weird trick. Oh, let's see. No, I can't do it. Well, maybe let's try it. You can create a turtle. Let's see if this works. Okay, that created a turtle object with no name. But it's a turtle object. And I'm calling a method on the object. Now over here, that in the picture, that would be a turtle object with no name, but I call a method on it. Let's see if it lets me do this. Wait, slow. There's that turtle. No, let's see. Oh no, notice I've got 3 turtles here in this world. Okay, one turtle was Yertle. That's that turtle. Okay, then another turtle is Yertle 2. That's this turtle. Notice I see the word new 1, 2, 3 times. That's 3 turtles. And then down here in the other world, I use new once. That's that turtle. So I've got 4 turtles because I used the word new turtle 4 times. Okay. This turtle here is the guy with no name. The turtle with no name is that one there. See, he was created and he just moved straight over to the edge of the world. So he moved 300. And this is a 300 by 300 world. So he was created and moved without ever giving a name. So what that shows you is this is not the turtle. It's a name for the turtle. Okay, I can create a turtle and tell him to do something without giving him a name. Now, since he doesn't have a name, I have no way of giving him a second command. See, I actually, it's not very useful to do this because I have no way to refer to that turtle anymore and give him a second command. I created him and gave him a command in one line, but now I don't have a way of referring to him in the second line, okay? But Java will let you create a turtle object without a name and call a method on it right away. So Yertle is not the turtle. Yertle is a name for the turtle. And that'll actually be important as we go along. These guys are, we have a clear separation in this picture over here. The right-hand side are the objects. The left-hand side are the names for the objects. Now, remember in the textbook, in the other textbook, we talked about the idea of very early of memory pictures. I think it was stack diagrams back in chapter, was it chapter 2, I think? See, memory diagrams back in chapter 2, this idea that you would have a variable and what it holds. And along with memory diagrams, you also had okay, so you have memory diagram, and then I guess it was the next chapter, you had the stack diagrams that included the memory diagram. So you want to draw pictures of your code. So you have memory diagrams that say, I have a variable and a value in that variable. And then these memory diagrams were combined with methods to give you these stack diagrams, which include the stack, the method name, and its variables. That's what I'm drawing over here. I'm drawing essentially a version of I'm drawing a version of these stack diagrams, but one that includes objects. Okay. These are primitive variables. The variable holds the value. These were ints. Okay. Here are memory diagrams using objects. And this is the variable in the memory diagram. And now there's this other part of the picture, the objects. The variables point at the objects. And this is something we're going to be talking a lot about. This is this memory diagram for objects. Okay. The variable names aren't the objects anymore. When we do this kind of stuff, this is just a name for the object. Okay. This is a name for the object, and it's a name for the same object that Yertle was a name for. That created the object. That created this object. That gave the object that name. This line of code gave the object its second name. This line created an object with no name, so it would just be an object sitting here in memory with nothing pointing at it, but we did use it. We created the object and called a method on it. Then this created this other name, and this created that object. This created that name for that object. That's this box here. And then this equal sign is the thing that says, but this name should name that object. Notice that the object exists by itself. We saw that here. The object exists all by itself. It doesn't have to have a name. So this creates the object, but this gives it a fixed name. And if you want, you can give it more than one name, like we did over here. This is tricky. Names, and actually this is truth everywhere in the world. Names are not the same thing as things. And philosophers talk a lot about this. Names and things aren't the same thing. You aren't your name. You exist without having to have a name. You as an object exist. It's convenient to give you a name. Instead of saying, hey, you all the time, it's convenient to give you a name. Programming is like that. The objects exist independent of the names we give them, okay? And we can actually work with objects with no names, though it's hard to. We rarely would want to do that. We'll see that we do it sometimes. It's not unusual in programming to program with an object with no name, but it's not convenient, okay? More often than not, we like to give names to objects. We name our children for a good reason, okay? So it's good to give a name to an object, but it's wrong to confuse a name with one of the most common mistakes in programming is to confuse names with objects. To think that Yertle is the object, because then you think that there's two, like, see here, you think there's Yertle turtle and there's Yertle4 turtle. And if you're not careful, you think there's two turtles there. Yertle4 is not another turtle. Anything you tell Yertle4 to do is telling that object what to do, which is the same thing as what Yertle is doing. There are two names for that object. There are lots of programmers out there who misread this, who think that there's a turtle called Yertle and a turtle called Yertle4. Well, there is a turtle called Yertle and a turtle called Yertle4, but they're the same turtle. A lot of programmers think that there's two turtles, and they get really mixed up about what this means. Some mistakenly think that this is a copy of that turtle. So some people would think that this creates a turtle, okay, that's that turtle. This creates another turtle, and this turtle is a copy of that turtle. So there's two turtles, one called this and one called that, and they're copies of each other. That's not what Java does, okay? That's not what it does. This is not a second turtle. It's just saying this name points at that turtle. It creates this picture over here. There are programming languages where this creates a second turtle, okay? It's not, Java has its way of working. The way Java works isn't the way all languages work. There are languages out there where this two lines of code would create two turtles. You would have two independent turtles, one called Yertle and one called Yertle4. And Yertle4 would start off as a copy of Yertle, but not Java. Java doesn't do it that way. Java makes Yertle4 what we call an alias for Yertle. And the picture looks like this. Two variables pointing at the same turtle object. And this is where things get tricky. This is where we have to start learning all these kind of ideas. Okay, so we've drawn over here a memory diagram for this code over here. Okay, so that's an important thing to be able to do, is to draw, and we'll see as we go along, that's going to be real important in this course, is to be able to draw memory diagrams that go along with your code. Okay, we've run out of time. Does anybody have any question? Another question before we quit? Anybody have a last minute question before we quit? Well, let me just show you. Copy. Dum-de-dum-dum. Paste. Save. I'm going to save it on my desktop. I'm saving something called Turtle Graphics, the example we just did. Okay, now compile. You get some warnings. You get a couple warnings down here because this code is kind of old. So you get warnings that you don't get in their web browser, but ignore them. There's 2 warnings, you just kind of ignore them. I'll see later if I can get them to go away. Okay, and then you click run. There's my 2 turtle worlds. They show up as 2 windows, and there's my 2. Yeah, see, it works in Dr. Java. And the 2 worlds show up as 2 different windows. Okay, so you can copy and paste this code directly into Dr. Java if you want. Okay, so you can work in their you can work in the browser with their code, read their examples, read their examples and think about them. And you can also just take their code, you can take any of their code and now copy and paste it into the new version of Dr. Java, which includes, if you're curious, remember, their code is in this config file. It's in that thing there. That's their code that does the turtle graphics. It's not part of the Java language. So that's what I put in that config file. That thing, it's got a little Java icon. That's a bundle of Java code that I added to Dr. Java so that you could do turtle programming in Dr. Java. Okay, we should quit. We have a couple minutes over. Anybody got any question? Any last minute question?
Nope.
Okay, let's see. What do I do next? I need to find my, oh, there it is. Okay, so I'm going to be able to stop sharing, and I'll go ahead and end the meeting. We'll meet on Wednesday again, and we'll keep talking about, we'll keep talking about turtles for a little while. We're going to talk about strings. Strings are going to be our other example of an object. Okay, see you Wednesday. Goodbye.
Have a nice day, Mr. Kraft.